Okay, so the kernel method was interesting, but it gets really pretty when we look at it in higher dimensions. Check this out. Let's say we have these points, the red and the blue, and we want to split them. The coordinates are these for the red points and this for the blue points. So again, we try to split them with a line and quickly realize that there is no line that can separate these points. So we need something a bit more complicated, and we'll use the kernel trick again. I am going to show you two ways to do this. One is to use a circular boundary, so a circle that separates the blue points from the red points. And the other one is to think outside the plane, so again, to think in higher dimensions. We'll now introduce the third axis, the z-axis. And now we can think that we're living in a building, and we're going to send the blue points to, say, the second floor of the building, and the red points to, say, the 18th floor. And now we're going to put a boundary on the 10th floor, and that's how we're going to separate the points. These 2 and 18 are not arbitrary. We'll see how they appear later. So basically we have two methods. The circle method, which sacrifices the linearity, and instead of using a linear equation, it uses a higher degree polynomial equation. And the building method, which sacrifices the dimensionality of the data. And now you don't have data in 2 dimensions, instead you have it in 3 dimensions. You still have linear boundaries in this method, but you have more dimensions. So the question is, which one do you like more, the circle or the building method? I'll let you think about it. And I'll tell you, they're actually the same method, and this is the kernel method. And I'll show you why they are the same. So let's look at the points again, and as we saw, no linear function can separate them. So maybe we need a different function to help us separate them. And here's a quiz. It's not a super easy quiz, so I'd like you to think about it. Which equation on the variables x and y, the 2 coordinates of the point, could come to our rescue when it comes to separating the points? The sum of the coordinates x plus y, the product of the coordinates x times y, or the sum of the squares of the coordinates x squared plus y squared? So think about it. If x and y are the coordinates of the point, which one of these 3 functions can help us separate the points? Enter your answer below.